Welcome. Today we're going to talk about subsets. This corresponds to our section 2.2. Set A is a subset of set B if and only if every element in set A is also an element of set B. We write this as A is a subset of B. And again, this is true if and only if, which we shorten to IFF, that stands for if and only if, every element in A is in B. So things to know is make sure you know that this symbol means a subset. I'm going to put a little red cloud around it. That means that the first is a subset of the second, okay? Which means that every element in A is in B. So let's take a look at this diagram on the bottom right, where you have two sets listed, and you can see the sets are contained in these circles, almost like a Venn diagram. We're actually going to look at a couple of Venn diagrams as well. But what this means is that everything contained in the blue circle is in set C. So that means that set C has 2, 6, 10, 14, and 4, 8, and 12. So if I were to write out in roster form everything in set C, that's going to be 2, 4, 6, 8, 10, 12, and 14. I could use words to describe that and say these are the natural numbers that are even between 2 and 14. I could also write that in set builder notation. But what this means is that everything contained inside that blue circle is in set C. Everything in the red circle is in set D. So D contains 4, 8, and 12. Notice how, since the red circle is completely contained within the blue circle, all the elements in the red circle are also in set C. But because the circle that is red only has 4, 8, and 12, the only elements in set D are those three elements. We would say that the cardinality, just a little review or a little reminder, the cardinality or cardinal number of set D would be 3, and the cardinal number of set C is 1, 2, 3, 4, 5, 6, 7. So let's answer some true or false questions. If subsets have to have every element in the other set to be a subset, is it true that D is a subset of C? Is every element in D, 4, 8, and 12, in set C, 4, 8, and 12? So this is true. D is a subset of C. Is C a subset of C? Is every element in C, 2, 4, 6, 8, 10, 12, 14, in C, 2, 4, 6, 8, 10, 12, 14? That is true. Okay? So every set is actually a subset of itself. But is C a subset of D? Is every element in C also in D? That is false. Because I can use one counterexample that shows that it's not. 2 is in C, but 2 is not in D. So therefore, C cannot be a subset of D. Let's look at this example. Again, we're going to write out what the set of A is in roster form. So A is the values 1, 2, 3, 4, and 5. Again, it's all the numbers that are contained within this circle. So 1, 2, 3, 4, and 5. Set B is contains the elements 3, 4, 5, 6. Okay, this is a Venn diagram as you're probably used to seeing in other classes. Things that are shared by both groups are in the middle. Okay, but everything that's in the green circle counts for set A. Everything in the purple circle counts for set B. So let's answer some true or false questions about this. True or false? Is A a subset of B? So is every element in A also in B? That is false, because A contains 1 and 2, which are not in set B. So that is false. Is B a subset of A? Is every element in B also in A? Well, 6 is in B, but it is not in A. So therefore, this is false. Is B a subset of B? Well, every element in B, 3, 4, 5, and 6, is also in B, 3, 4, 5, and 6. So this is true. So we can make a statement to say that every set is a subset of itself. That is true. Every set contains the same elements as itself. So therefore, based on the definition of a subset, it is a subset of itself. And then which Venn diagram would represent a subset relationship? And if we notice before, this one, because this entire circle was contained in this circle, this shows us a subset situation. This one did not, aside from a set being a subset of itself, because here you will have elements in this group, A, that are not in this group, B. So therefore, A will not be a part of B, or a subset of B, and B will not be a subset of A. So this symbol that I'm circling in purple means A is not a subset of B. Okay, so it's literally just our subset symbol with a cross over it. We do that a lot in math. If I want to say something's equal to one another, I use that symbol. If I want to say it's not equal, I just put a cross through it. Okay, we saw that earlier. This symbol meant is an element of, and this symbol means is not an element of. So we should be used to that kind of notation. This symbol represents that A is not a subset of B. And now we're going to look at this and determine which ones are subsets of each other and which ones are not subsets of each other. So comparing C and D. Is every element in C also in D? So C contains the elements 2, 4, 6, and 8, and D contains 0, 2, 4, 6, and 8. So every element in C is in D, so therefore C is a subset of D. I'm going to do that in a different color. Okay? What about C and E? C contains 2, 4, 6, and 8, and E is 2, 4, 6. Is every element in C also in E? Well, 2 is in both, 4 is in both, 6 is in both, but A is in C, but not in E. So therefore, C is not a subset of E. Could I say E is a subset of C? That is true because every element in E is in C. So this is true. But if I did the other way around and said C compared to E, or C is not a subset of E. What about C and F? Again, C contains 8, whereas F does not contain 8, so that is not a subset. And lastly, we look at set C and G. Set C contains the elements 2, 4, 6, and 8. Set G contains the elements 2, 6, 8, and 4. If you notice, they're the same elements, 2, 2, 4, 4, 6, 6, and 8, and 8. So therefore, all elements of C are contained in G. So therefore, C is a subset of G. Please watch part 2 of this video where we'll go into proper subsets and other important things for you to know about subsets.